Assalamualaikum and good evening. Today we're going to present about flame or fire sensor. I am Ahmad Imam Hakimi bin Rodin and my fellow friends Muhammad Nurbani bin Abdullah and Muhammad Aikar bin Muhammad Rusli. This is a system description for our project. In this final project, we will interface the flame sensor with Arduino. We will design fire detector using flame sensor and Arduino for detecting fire. The project uses a flame sensor and an Arduino board to create a fire alarm or detector. The sensor detects infrared light wavelength ranging from 760 nanometer to 1100 nanometer generated by the fire flame. The YG1006 sensor, which is a high-speed and high-sensitive NPN silicon phototransistor, was used in the majority of flame sensors. When a flame is detected, the LED changes from green to red. Next, this is basically our flowchart. For the first step, we're going to start the sensor, and then the sensor will collect information from the sensor. If the sensor detect the fire below 100 nanometer, the buzzer and the LED will turn on. But if the flame sensors detect the fire more than 801 nanometer or below 1200 nanometer, LED and the buzzer will turn off. This is a system diagram for our final project. We use flame sensor. In this flame sensor, we use two output, which is analog output and digital output. And then we will detect phototransistor. In this system diagram, we have a output that is DO LED. That is a digital output for the system diagram, and for the analog output is beside phototransistor.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Nurbani bin Abdullah, TB 20005. I will continue what Iman Hakimi already present. Okay, in this project, we use Arduino Uno R3 for program the code, sensor for fire detection, buzzer for giving alarm, LED for light indicator when fire detected, and lastly breadboard and connecting wire to combine the component into one circuit. Okay, this is the output simulation in Visual Studio. The first one is the waveform. Okay, the waveform will detect from range 0 to 1200 nanometer. Okay, as we can see from the waveform and output from Visual Studio, when the fire detected by the sensor at range 50 nanometer, the buzzer and LED will on and give command that the fire close around. While when the fire detected at range 732 nanometer, the LED will on and the buzzer will off and give command that no fire around. Okay, finally, when the fire detected at range 1023 nanometer, both buzzer and LED will off and give command that no fire around. And for coding, as you can see in the coding, we use buzzer and LED as output in this project. The buzzer connected to the Arduino at pin 12, and the LED connected to the Arduino at pin number 9. Okay, for the flame sensor, we can see from the circuit that I show from last slide, we connect it to the pin A0 at the Arduino. as analog input. Okay, so here we have three cases that we already made for this project. The first one, when the fire between 0 to 100 nanometer away, the buzzer and LED will be on. The second case was when the fire between 101 to 800 nanometer away, the buzzer will off, but the LED will be on. And for the last case was when the fire between 801 until 1200 nanometer away, the buzzer and LED will be off. Okay, that's all from me. I will pass to the next presenter, Muhammad Aikal.
Assalamualaikum warahmatullahi wabarakatuh. Thank you to the Muhammad Nurbani for the explanation of the coding. Okay, so my name is Muhammad Haikal bin Muhammad Rusli. My turn is for explain manual user and equipment. And last is conclusion. Okay. For manual user, first and foremost, when the system or project is active, the flame detector as a sensor will detect the light of the flame close around depend distance flame to the sensor. So if the flame is between 0 to 100 nanometers, sensor will detect. Then both the LED and buzzer will light up. After that, the one that's turned on if the flame is between 101 to 800 nanometers would be LED only. Last, if a sensor to flame is in between 801 to 1200 nanometers, neither the LED nor the buzzer will switch on. Okay. So for equipment, bill and materials, uh, Arduino basic kits consists of 90 ringgit Malaysia. What we got is Arduino Uno R3, flame sensor, buzzer or LED, breadboard and connecting wires. So for the conclusion, in conclusion, as part of building a safety strategy, a fire prevention system should be installed. Without a fire prevention system, a person within the structure face a significant danger of death in the event of an emergency. The approved system for use such as fire alarm system, sprinkler system, fire pump and smoke control system uh, take some action to notify of the fire and smoke condition, delay the progress of the fire or but put out the fire entirely. Okay, thank you. So this is our
Okay.
video.
Ya, kita.